Now there's a better way to get optimized pump efficiency at 50% of the design flow rate, the Armstrong Design Envelope IVS pump. Our demo unit is a miniature installation that demonstrates how the Design Envelope IVS pump simulates operation in a live setting. It represents a simple, closed, pressurized building HVAC water system for cooling or heating. The three essentials of the pumping package are a perfectly matched vertical inline pump, motor, and intelligent variable speed controller. The pump's performance curve is pre-programmed into the controller. What you see is a duty standby pump configuration with integrated controls and sensorless programming for a 4312 vertical inline twin pump equipped with a 1.5 horsepower motor. It is equipped with a suction guide located at the pump suction to prevent debris from entering the pump and minimize turbulence that could cause unwanted noise and vibration. A 2-inch triple function valve on the pump discharge offers a check feature, isolation feature, and throttling capability to keep the pump on its curve during operation. Downstream of the pump discharge, we have a two-way control valve that would be typically located near a load in the system, opening and closing depending on system load requirements. A 2-inch Venturi-style CBV balancing valve is typically installed downstream of the load to balance the branch. An optional pre-wired bridge for our dual-arm or twin pumps allows the standby pump to start on fault or to alternate for equal pump wear. Automatic alternation can be adjusted to a desired time setting on site, anywhere between 1 minute to 7 days of alternation time. A traditional installation typically includes a differential pressure sensor located at the furthest point in the system. Sensorless programming eliminates possible errors in sensor selection, installation, and wiring back to the drives, which can occur during commissioning. All sensors come with the nuisance of costly replacements and repairs that can occur over time, in addition to the capital costs of the sensors themselves. The Armstrong Design Envelope IVS pump eliminates sensors altogether. The IVS controller adjusts the speed of the pump to meet the immediate load of the HVAC system. The pump responds instantly to the system load and draws only the power required to meet the load. Sensorless control mimics the performance of a sensor by using a pump's relationship between its flow, head, speed, and power. The controller's memory is programmed with the pump performance characteristic data map. During operation, the controller monitors the power and the speed of the pump and uses this data to establish the hydraulic performance and precise operating point of the pump at all times. The controller monitors the power and speed of the pump. Here you can see the pump performance curve, one pump operation. From the embedded sensorless data, the pump's control curve is mapped between two reference points, Hmax and Hmin. Hmax is the duty set point while Hmin is the minimum pressure setting. This is factory set at 40% of the duty point. This value can be easily changed on site to suit specific system performance. Since a system's friction losses have a quadratic relationship to flow, the sensorless control curve adopts a quadratic form for optimum energy-efficient operation. We have our full capacity design envelope speed curve shown in the dotted blue line. The impeller is trimmed to the motor power and pump best efficiency point instead of the duty point for full capability of the installed motor. The design speed of the pump in the system is shown in solid blue. The three columns at the bottom right of the screen display the pump performance and its operating costs by going from full speed setting to design point to actual pump performance in order to satisfy the system load as the valves open and close in a system. As we begin to throttle the two-way control valve from the fully open position, we can see the quick responsiveness of the sensorless control. We can see the duty point of the pump begin to change. As the differential pressure across the valve increases, the pump reduces in speed following its control curve to match the required system pressure at the current flow. Flow and head measurements are available on the IVS keypad display. It's also possible to export these values to the building automation system. The flow display that is inherent to the drive has a 3% accuracy level at part load. That rivals industry flow meters. Because we have eliminated pressure sensor positioning issues, you save on commissioning costs. Impressive energy reductions meeting and exceeding ASHARE 90.1 and reduced pump work result in a potentially longer pump lifespan. That allows you to save on operating costs. Vertical inline split coupled pumps are easily serviced, allowing for reduced maintenance costs. And we have cut back on capital costs by eliminating a pressure feedback sensor and a flow meter. Armstrong offers intelligent variable speed equipment with demand-based controls to enable a wide range of design day performance requirements. This control method ensures that your HVAC system is more efficient at all part load operating points. You only operate at actual system demand at any given moment, thereby achieving unparalleled pumping efficiency and performance. A 50% part load condition results in an energy saving of over 70% when compared to full speed, meeting ASHARE 90.1 energy standards. Armstrong Intelligent Variable Speed Controls are integrated to the pumping unit, creating a smaller package footprint and lower installation costs. You only pay for what you really need. Compare this to wall-mounted loose drives, which have higher installation costs and more space requirements. In the example of loose drives, controls installation and pump installation are typically handled separately, resulting in potential commissioning and performance discrepancies and therefore higher installation costs. Building owners who change out the constant speed pumps to a new design envelope IVS pump can see a return on investment in less than 2 years. Because of the integrated design and sensorless programming, the design envelope IVS pump is ideal for retrofit plug-and-play type applications. All Armstrong design envelope products provide 3 key benefits: minimize project risk at the design, installation, and operation phases, reduce capital, design, and installation costs, and increased energy savings.